Howdy everyone, welcome back for the Chapter 8 tutorial video. We'll be looking at stoichiometry and what we normally will do with it, using it to find out how much of a chemical we could make or would be needed. And in this case, we'll be looking at comparing two givens for reactants to find out the limiting reactant, find out the theoretical yield, and then to take that with some additional information from the problem and determine the percent yield for a reaction. So with this one example, we'll be able to look at most of the material from Chapter 8 and have a pretty good idea of how to set it all up. All right, so here we go. This is problem 8.65 from the text, where it says we've got this reaction of lead ions with sodium chloride will make solid lead chloride and some sodium ions. And it tells us that they took 195.7 grams of lead ions and added 135.8 grams of the sodium chloride. And in the first part, they want us to find the limiting reactant and the theoretical yield of the lead chloride. So that means we're going to be doing two different stoichiometry problems. We have two different givens, one for the lead, one for the sodium chloride. We're going to use both of them to find out, okay, how much lead chloride could we get? And when we compare those two answers, we'll know which reactant was limiting. All right, so we're going to do a three-step stoichiometry. Remember, we always start with our given, so I'll start with the lead here of 195.7 grams of lead. Now, some people get confused when they see ions, like, does that change the mass? How do I adjust for that? Remember that electrons are so small, they're like 2,000 times smaller than a proton or a neutron, that they're so small, losing 2 electrons does not change the mass in any way that's going to matter to these calculations. There are some techniques in chemistry where, yes, it might matter. Not in Gen Chem, not what we're doing here. So we just say, okay, for this case then, the molar mass that we'll use, we always convert from grams to moles with molar mass. So we'll put grams of lead on the bottom. We will put moles of lead ions on the top. And we look it up, so we use the same number from the periodic table. Where am I looking at? 207.2. Right, that's our first step. First step is always get to moles. Our second step for stoichiometry is always convert between moles. Go from the chemical you're starting with to the chemical you're interested in. So in this case, we're going to put moles of lead ions on the bottom, and we'll put moles of lead chloride on top, because that's what we want to find out about. The problem said, what about the lead chloride? And so we look at the balancing and we see it's 1-to-1 for both, so that's great. And then we'll just go ahead and say, okay, third step, it's always get to your answer unit. In this case, we want to find out about grams of lead chloride. So we'll put moles of lead chloride on the bottom so it cancels out. We'll put grams of lead chloride on top. And then we say, okay, we need the molar mass. So this time it's PbCl2. We have to add it up. It's more than just one thing. So it's 207.2 plus 35.45 for the chlorine. But there's two of them, so plus another 35.45. And you get 278.1. And that looks right. All right, and then that's our setup. If we look, all the units cancel out. Grams of lead ions cross out. Moles of lead ions cross out. Moles of lead chloride cross out. We're left with grams of lead chloride. So now we're just going to do this math. 195.7 divided by 207.2 times 1 for that middle fraction, so we can skip that, and then times 278.1, and we get 262.7 grams of lead chloride. Now that might be our theoretical, but we don't know because we have another given. We have to check both of them. So I'll do this one in a different color just so we can tell them apart more easily. But we'll do the same three-step process just with the other given. So now we've got 135.8 grams of sodium chloride. And again, the first step, get to moles. We've got grams to moles. That's molar mass. We add it up off the table for grams of NaCl to go to moles of NaCl. I happen to know this one's 58.44. I use it too much. But there's that number for the molar mass. Second step, convert from moles, the chemical you're starting with, to the moles that you're trying to get to. So I got to get rid of moles of sodium chloride on the bottom, and I want to go to moles of lead chloride on the top. And then I look at the balancing. It's 1 mole of lead chloride, but it's 2 moles of sodium chloride, so that's good to know. And then the third fraction is still get to what your answer wants to be. In this case, the grams of lead chloride. And the nice part, we've already got that molar mass, so I can just copy that, 278.1 grams of lead chloride over 1 mole of lead chloride. Again, check for units. Grams of NaCl cancel, moles of NaCl cancel, moles of PbCl2 cancel. We're left with grams. We just type it in. So 135.8 divided by 58.44 divided by 2, and then times 278.1, and we get an answer of 323.1 grams of lead chloride. All right, so now we've got our 2 answers. And, well, they're not the same answer, so that means one of them is our actual theoretical yield here. So what we do there is, remember, the limiting reactant says I can make a certain amount, but then I run out. Then it's all gone, and you can't make any more. So we want the smaller number. In this case, the 262. This will be our theoretical yield. And then the chemical that gives you that amount, that was the limiting reactant. So in that case, that means, okay, the lead ions are limiting because they gave us the smaller amount. They ran out first. So that's how you do part A. Now, in some Stoic problems on homework, on the test, you won't have to do both. It might just be, here's one given, here's one chemical, find out about the other chemical. Okay, in that case, great. Just do one conversion and you're done. But when they give you 2, this is how you do it. You do one calculation for each, compare the answers, you want the smaller answer. All right. Now we'll move on to part B of this problem. So it says now, if 252.4 grams of lead chloride were obtained, what was the percent yield? Well, percent yield is always equal to the actual over the theoretical and then times 100%. So the actual 252.4 grams. The theoretical from the previous page, 262.7 grams. We'll just divide that and then multiply by 100%. So 252.4 divided by 262.7. Then times 100%, we get, what would that be? 96.08%. 4 sig figs, 4 sig figs, 4 sig figs. And so that would be our answer there. And so with those 2 steps, you're going to be able to handle Chapter 8. Remember, the 3 key steps of stoichiometry. Get to moles, switch moles to the chemical you're interested in, get to your answer unit, which is usually grams. There may be some problems where they use a delta H to get to joules or kilojoules for energy. But then, okay, well, what do I want? I want energy. Use the provided information to get there. All right, so I hope that was helpful. I will see you again for Chapter 11 on gas laws. Until then, have a good day.